Hello everyone, I'm Xiaoha. If you've written custom shaders in Three.js, you're probably familiar with on-before-compile hacks or writing GLSL strings by hand. These methods work, but they often lead to code that's difficult to maintain and reuse. Today, let's talk about the official solution from Three.js TSL, which brings us a more modern, engineering-focused shader workflow. First, TSL. Three.js shading language is essentially a shader construction system and abstraction layer. Look at this diagram. We work on the far left, writing logic in familiar JavaScript or TypeScript. The TSL engine in the middle acts as a compiler. Gesture sweeps to the right. It builds our high-level code into the low-level shader language required by the target platform, GLSL for WebGL or WGSL for WebGPU. This process is fully automatic. The immediate benefit of this abstraction is improved code readability and maintainability. This image compares the two approaches. On the right is the traditional shader material method, where GLSL code exists as strings, lacks type checking, and is disconnected from the JavaScript logic. On the left is the TSL approach, which is declarative and node-based. Every operation is a reusable function or node, making the logic clear and structured. This not only reduces the chance of errors but also makes code reuse and refactoring significantly easier. In short, TSL transforms shader code from imagic strings into the modular code we manage and maintain daily. Besides improving the developer experience, TSL also solves several key engineering problems. First, cross-platform compatibility. WebGPU is the future, but we can't abandon WebGL support just yet. TSL smooths over the syntactical differences between GLSL and WGSL. A single set of node logic you write can run seamlessly on both rendering pipelines. This significantly reduces the cost of project migration and maintenance. Second, non-destructively extending existing materials. In the past, if you wanted to add a special effect to a standard material, like the subsurface scattering lighting model in List's Flame Lotus, you'd likely have to copy and modify large chunks of Three.js's internal GLSL code. This is tedious and prone to breaking with version updates. TSL, however, lets you use mesh standard node material to programmatically replace or extend a specific part of the material, like its color node, or normal node. You can preserve the powerful lighting calculations of the PBR material and only inject the custom logic you need. This is a much more stable and modular way to extend materials. Third, leveraging the GPU for general-purpose computing. The complex fluid simulation shown in this image is driven by intensive mathematical calculations. TSL, combined with WebGPU's compute shaders, provides a JavaScript API for executing general-purpose parallel computations on the GPU. This means we can offload data-intensive tasks, like physics simulations for particle systems or complex algorithms and data visualization, from the CPU to the GPU. This frees up the main thread and dramatically improves application performance. TSL provides a structured entry point for these kinds of computational tasks. So, to summarize, TSL isn't just for creating visual effects, it's an engineering solution that improves the shader development workflow, code quality, and application performance. It provides code modularity, platform compatibility, material extensibility, and access to general-purpose GPU computing. If this overview has sparked your interest and you feel you've learned something new, please give this video a like. It's a huge motivation for me and helps the channel reach more developers. And if you're ready to move from theory to practice with me, make sure you hit that subscribe button and turn on notifications. Because in the very next video, we will be opening the code editor and building our first TSL node material from scratch. You won't want to miss that. For those who want a head start, I've linked the Three.js TSL website directly in the description below. It's an excellent place to explore the documentation. Thanks for watching, and I'll see you in the next one.